Alright. Hey everyone, welcome back to another session with OneClass. My name is Bassam, and today we're going to be going through some algebra problems at the high school and university level. Let me just adjust my chair here. Okay, so a little bit about myself. I'm an engineering graduate, so we're going to go through some algebra problems, as I said before. And we'll get started over here. Just let me adjust a little bit. Okay. Alright, let's get started. Okay, so this is the first question. Question number 1. Here we're asked, how do you find the circumference of a circle with a diameter of 6 centimeters? So we have some circle, and it has diameter of 6 centimeters. Okay, so what we're going to do here is we're going to go through the junior tutor's answer, go step by step, and try to verify that it's the right solution, and then we're also gonna go through step by step on the whiteboard over here how to get the correct solution as well. So starting off, to determine the circumference, we have the diameter. So this is what's given, 6 centimeters. So they give the answer right away. Let's go down to the explanation. So we have this equation right here. C for circumference is equal to 2 pi times diameter divided by 2. So diameter divided by 2 is just the radius, so I'll write that over here. R for radius, and the equation that represents the circumference for the circle is C is equal to 2 pi R. So this is a very important equation to know offhand. I'll just highlight it over here. And this is what you'll need to solve this problem. So right away we can see that diameter is given in the question, and we'll substitute that in to get to our final answer. So we can see the junior tutor went with these steps, so let's go through them on the side over here. So we have C equals 2 pi, our diameter is 6 centimeters, and divided by 2. So we know here we have 2 pi times 3. 6 divided by 2 is just 3. And then we have 3 times 2. So we're going to multiply this 2 with this 3. And we'll end up with 6 pi centimeters. So we can use our calculator to get the exact answer, or we can multiply by 3.14. So we can do 6 times 3.14 for pi, or we can just type in pi into our calculator and multiply by 6, and we'll end up with 18. This is approximate 18.85 centimeters. I'll put squiggly for approximate. Okay, so we can see here that the junior tutor obtained the correct answer, and they followed a similar process. So we can mark this question as correct. Great job. And we'll move on to the next question. Okay, so question number 2. Question number 2. So in this question, we're not really asked anything specific. What are the basic algebra problems? So I'm going to go through with what the junior tutor wrote over here to help kind of guide the answer to this question. So to determine, this is what we gotta figure out, just an overview of basic algebra problems. There's a 1-step problem and 2-step, so they have 1 step over here and 2-step. And then they have slope over here, slope intercept. So they go through a couple of problems. We'll go through these. So first one, 1-step problems are those solved using a single step. So I'm assuming step by division, multiplication, subtraction, addition. This involves variable on one side of the equation and everything else on the other side by doing the opposite operation. So yep, just like we thought, on both sides of the equation or equal sign. So here they give us just a simple algebra problem. We have 3x is equal to 6. So the goal for this example, is to isolate for x, and in this scenario we just divide by 3 on both sides of the equation, and we end up with x is equal to 2. So we know 3x divided by 3 will give us x, 6 divided by 3 will give us 2. So there's a one-step algebra problem. So two-step, we get a little more complicated over here. So if we had the following example, so here what they're saying is it's two-step because for us to isolate for the variable, which is y in this scenario, we need to do two operations. So we can see the first operation over here is multiply, and the second is addition. So we'll go through this. Just give me a second. I'll just erase this right here. Okay, so we have this equation, y minus 1 divided by 3 is equal to 2. So we want to isolate for y. The first step is multiplication. We want to get rid of the 3 in the denominator. So we multiply both sides by 3. I'm use a different color over here. So we'll say times 3. So I'll use a dot for 3 instead of an x so we don't get confused. So multiply by 3, and then I'll put brackets over here, and then multiply by 3 on this side as well. So we can see that this 3 up here and this 3 down here get cancelled, and we're left with 2 times 3 on the right side, and what this gives us is 6, and we're left with y minus 1 on the left side. So that's the first step over here, similarly to what the tutor did over here. And then the next step is we add 1 to get rid of this 1 on both sides of the equation. So I'll do the same thing. I'll use the same color. So we'll say plus 1 and plus 1. So for the equation to hold true, we have to do the same thing on both sides of the equation. So it doesn't affect it at all. All we're doing is just algebra to get to our final answer. We can see that the 1's cancel out, and we're left with y is equal to 6 plus 1, which is 7. So here they get the same answer, and this is correct. So next example is for slope. So in a scenario where we're calculating for a line, or we're given 2 points, so here they're saying the m represents slope. So let me erase this over here. So we know the equation for a line is y equals mx plus b. So m is a constant, b is a constant, y is a variable, and x is a variable. And the x, y variables are just the ones on the coordinate diagram. So we'll have x-axis and y-axis. So here we're given 2 points, 0, 1 and 4, 3. So I'll write these over here, 0, 1 and 4, 3. 4, negative 3. So this will be about, 0 on the x, 1, so it will be somewhere over here. And then 4, negative 3, we have somewhere over here. So it will be something like that, and we're trying to find the equation for this line that passes through these 2 points. Okay, so what we want to do here for this slope is kind of algebra, just plugging into this equation and finding the slope, and then we can use that to determine the slope. So we can say this is x1, y1, and then this is x2, y2. So we know the slope. So looking over here, we have y2 minus y1, so negative 3 minus 1. So y2, which is negative 3, minus 1, which is y1. And we have x2 minus x1. So divided by x2. Oh, whoops, let me write that what that is. x2 is 4. And x1 is 0, so minus 0. So we can see on the top we have negative 3 minus 1, so that'll give us negative 4. And on the bottom is just 4 minus 0, which is just 4. So negative 4 divided by 4 is just negative 1. And that's the slope. So if we're given a slope kind of problem, this is how, with 2 points given, and we want to find the slope for this line, we can do that. So now we know that the equation is y is equal to negative x plus b. So the negative here is negative 1 for m. So the question doesn't go on to solve for b, but let's say you wanted to do that. All you have to do is sub in one of these points. So if I substitute in 0 and 1 to this equation, we know 0 is x, so it will be 0, and then y will be 1. So we'd have 1 equal to 0 plus b, and we know b is equal to 1. So we know that the actual equation is negative x plus 1. We can also verify this by plugging in the second point, so this point over here, 4 and negative 3. So we know y is negative 3 on this side, and if we plug in 4 for x, we have negative 4 plus 1, which is negative 3. So this equation is correct. Okay, so the last example given here is so these are problems that involve slope-intercept. So they're giving a slope-intercept problem. So the slope-intercept line between 0, 1, and 4, 3. So 4, negative 3. So they go on to answer. So do what we did here. They substitute in y equals mx plus b. They put in the negative 1. They know at if we plug these values in, we'll end up with positive 1 for the b, and they end up with the correct answer. So similarly to what we got, this is correct. So here they give a quick summary of how to do this. So this is just the general overview for some common algebra problems that you could find in your homework or in a test. So correct answer. Great job with explanation. Okay, we'll mark this as correct, and we'll move on to question number 3. This is question number 3. Alright, what is a quadratic expression? So quadratic is the key word here. This is what we're trying to figure out. So whenever you're given in a question, what's a quadratic expression, or find the quadratic expression based on some givens. So looking at the Junior Tutor's answer, a quadratic expression is a mathematical expression with a degree 2. Okay, so this is key to know for a quadratic. This means that the variables must have 2 as their highest exponent. Examples are this and this. So what does this mean? Let's write this over here. 2x squared minus x plus 4. So this is the first example, and then y squared minus 16. So whenever we're talking about the degree of a mathematical expression, so here degree 2, I'll use a different color. We're talking about the exponent, so this right here. So what is the variable with the highest degree is what is the variable with the number on top right here. So this number over here and this number. So what is the highest number there? That'll give you the degree. So this is degree 2. This is degree 2. Let's say I wanted an expression with degree 5. All that would that be would be x to the power of 5 plus something else, so let's say x plus 1. So this will be degree 5 because that exponent is 5. So for a quadratic expression, however, we're really looking at something raised to degree 2, which is the examples given. So whenever you hear a quadratic expression, It's what's the highest exponent on the variable. So it doesn't have to have all three components. So we have x squared, x to the power of 1, x to the power of 0, which is just 1. We could just have x squared. So the equation x squared by itself is also a quadratic expression because the variable with the highest value exponent is x squared, which is 2 over here. So we know this is also a degree 2. So that's a way to think about, what is a quadratic expression? If you're giving a bunch of expressions similar to this, how can you, mark them out? Or if you're given in a multiple choice question, which ones are the quadratic expressions, which ones are not, you are able to just look at the highest degree and determine that. So correct answer. Great job. Alright, let's move on to the next question. So here we have question number 4. Alright, so here we're given x squared plus y squared. So no real question. I'm going to base my solution based on what the junior tutor answered. So here they have the expression x squared minus y squared can be viewed as a binomial with each term as perfect squares and has subtraction as a mathematical operation. So I'm assuming there's potentially a typo. This should be a minus sign based on the junior tutor's answer. So we'll look at this. So generally for a binomial is, for this binomial, x squared minus y squared. So I'll write that over here. So it could be any numbers. So it could be x squared minus 4, x squared minus y squared, same idea. We have something that's called the difference of squares. So this over here, the difference of two squares, or the difference of squares. And essentially, if you have two kind of components here, and you can square root each one, so x squared square rooted, as shown here, is just x, y squared square rooted is just y. This is kind of the format it ends up being. So it'll be a product of two binomials with alternating signs in the middle. One is addition, one is subtraction, so as shown here. So this would be equivalent to x plus y and x minus y. You might be thinking, why is that the case? One way to think about this is we can just use FOIL to expand this. So first outside, inside, last. So we can just use common simplification to see if we end up with the same expression right here. So we can say first is x times x, which is x squared. Use a different color. And we have outside, which is x times y, so times negative y, which is minus xy. And then we have inside, so y times x, which gives us plus xy. And then finally, I'll do this one in red, we have FOIL last. So last is this right here, y times negative y, so we have negative y squared. So we can see right away this term and this term are identical, so they cancel out and we're left with x squared minus y squared. So whenever you're in a situation where you see two kind of terms that can be squared and there's a minus sign in between, there's a difference of squares and it follows this format. So another example you could think of is x squared minus 4. So square root of 4 is 2. Square root of x squared is x. So this ends up being x minus 2, x plus 2. So same idea, difference of squares, and we end up with the same solution as indicated by the junior tutor. Alright, so we'll mark this as correct. So correct answer. Great job. And we'll move on to the next question. Okay, so question number 5. Alright, so here we're asked, what is decimal notation? Alright, so a decimal notation is a representation or a fraction using the base 10 and consisting of any digits and a decimal point. The digits on the left of the decimal point have a multiple of a positive power of 10, while the digits on the right have a multiple of negative power of 10, to illustrate. So this is kind of like a word explanation. Oftentimes it's hard to understand what does this even mean, but we'll go through this. So here they give you a long number, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then same thing backwards. But essentially what they're showing here is this decimal point right here. And these commas are just to make this number easier to read, but you don't have to worry about those. Just worry about this decimal point. This is the main thing. So we can see here, this is the ones, tens, hundreds, thousands, and so on the left side of the decimal point. And on the right side of the decimal point, we have the tenths, hundredths, thousandths, 10,000ths, and so on. So here they give some example looking at the number, the 9. So looking at this number, the 9 in the 10th place. So the 10th place is right here. We have the number 9. And the 7 in the thousandth place, so this 7 over here, can be written as follows. So we can write this 9. So what they're trying to say here is if we have something like 0.9, we can write this as 9 divided by 10. And that's where the tenths comes in. So because we have a fraction where the 10 is on the bottom, that's why you have the tenths. Similarly for the 7, so we have 7 and thousandths, so we know there's 1,000 in the denominator. So 0.007, this is 0 over here, is equal to 7 over 1,000. So that's kind of an overview of the general notation, general decimal notation. So if we were given a number like 24.825, okay, just looking at this, we can say this is the ones, this is the tens, so you know 24. But if the more challenging part of this isn't really the left side, it's more knowing the right side. So this isn't the ones, this is the tenths. Why? A quick way to remember this is if you look at just this column separately right here. So if we had just 0.8 by itself, that might be a little clearer of what this represents. So if you divide 0.8 by, if you want to represent this with base 10 in the denominator, you know that this is equal to 8 divided by 10. So if you take 8 divided by 10, that's equal to 0.8, or 80%. So this is also equivalent to 80%. So that's another way to think about it. But yeah, that's essentially a general overview of the decimal notation. Let me think about if there's anything else. So just looking at this number again, so we can see that the 2 right here is in the hundredths column, and the 5 here is in the thousandths column. So you have 0.825, and that's kind of, use the same idea if you want to split this up. So it would be 2 over 100, 5 over 1,000, if you want to represent these separately. Okay, so this is the correct answer. Great job. I'll leave a comment here. And we'll mark this as correct and move on to question number 6. Alright, so in this question we're asked, what is a real root? So real roots are those real numbers that are solution to a given equation. For example, given this quadratic expression, and we find the roots here. So the real root here is 1. So whenever you have a quadratic expression, usually you think about them as roots, but the full term for it is a real root, mainly because there's no imaginary component. So if you look at the example given, so we have x squared minus 2x plus 1. Let me actually erase this. I'll write that a little clearer. X plus 1. You want to factor this out to find the roots. So looking at this, what I do when I try to look at this expression, I think about, okay, what can I well, this is actually a special case. This is a perfect square, mainly because you can see over here it's x minus 1, x minus 1. So what I think about when I'm doing this is these are small kind of numbers. We have the coefficient 2 here, so I'll circle that in red. This coefficient and this coefficient, and we also have a 1 in the front, so that's another thing to think about, but really we're only looking at the other two coefficients. And you want to think about, okay, if I have the last number as 1, the last two terms, so here x could be plus or minus, should be equal to 1. So this number, negative 1, times negative 1 would give us 1. So we don't know necessarily if it's negative or positive. We can also have positive 1 times positive 1. It also gives us 1. So that's also an option. But that's where this term over here comes into play. So negative 2, okay, the other step that you got to go through is, okay, this term and this term added together, what does that give us? So negative 1 plus negative 1 gives us negative 2. If they are positive, plus 1 plus 1 would be positive 2, and that's where this kind of doesn't hold true anymore, and we end up with this. So this is equal to 0 over here. And when we're at this stage, so this is just a perfect square, so this could also be represented as x minus 1 squared. Essentially, we know we just set the stuff in the brackets to 0, so we have x minus 1, set that to 0, and then solve for x, so that's x equals to 1. And that's our root, so that's x, the first root, and then the second root is the same because we know it's also x minus 1. But essentially this is a real root because we're able to factor this out, and we're able to get these two separate expressions, and we're able to solve. So if we're able to go through this process regardless of what the initial quadratic expression is and find real roots, so real numbers, there's no situation where you end up having to square root a negative number, then you know these are real numbers, real roots. They become imaginary roots when you start square rooting a negative number. So if you have to square root negative 2 or any other negative number, then that becomes an imaginary root. But in this situation, that's not the case, and we end up with real roots. So correct answer. Great job. Mark this as correct and move on to the next question. Alright, question number 7. Alright, so question number 7 over here asks us, how do you find a range of y is equal to x plus 5 divided by x minus 2? So keyword here is we want to find the range of this expression. So we have y is equal to x plus 5 divided by x minus 2. So this is the expression, and we try to find the range. So let's go through the Junior Tutor's answer. So what is required is, as we said before, the solution is essentially what you do here is you flip the x's and y's. So wherever there's an x, you put a y, and wherever there's a y, sorry, you put an x. And then after you've done this step, you solve for y. So this is what they've done over here, and they end up with the solution. So let's go through this. So we'll switch this up. So we'll have x on the left, and then y plus 5 divided by y minus 2. So we'll multiply both sides by y minus 2. So let's use a different color over here. So times y minus 2, and then times y minus 2. And we end up with, we have x times y minus 2 is equal to y plus 5. And then we just expand this out. So we have xy minus 2x is equal to y plus 5. So here we're trying to isolate for y. So we want to put all of the y terms on the left side. So we'll subtract y from both sides and we'll add 2x. So use a different color. So we'll say minus y over here, minus y on the left side, and plus 2x, and plus 2x. So we're still at the same equation because we're doing the same to the left side and right side. That doesn't change the equation because these just cancel out. We're just trying to eliminate some terms and make sure that the y's are on the left side. So right away we can cancel the 2x's here. And we can cancel out the y here and the y here. Excuse me. So we'll cancel out the y here and the negative y here. And what we end up with, so we know this cancels out, this cancels out, this cancels out, and this cancels out. So we're left with xy minus y is equal to 2x plus 5. And then I'll erase this stuff. Make some space. Okay, so we'll move this up here. Or I'll put an arrow like this on the side. So we'll factor out the y. So we have x minus 1. So we just factor out the y on both terms, and we end up with x minus 1 times y is equal to 2x plus 5, and then y is equal to 2x plus 5. We'll divide by x minus 1 on both sides of the equation, so I'll write that out more clearly. So divided by x minus 1, and divided by x minus 1. So these two cancel out, and we're left with y on the left. And we still have divided by x minus 1. So I'll erase this step. Erase all this. So this is what we end up with. And to find the range, we're really looking at the denominator here. So we know we set the denominator to 0. So we'll say x minus 1 equals 0. And then we solve for x, so we get x is equal to 1. So we know the denominator cannot be equal to 0 because if we have something divided by 0, it'll just be undefined. That's just a general rule for algebra. And then we know that for this function, the range is where x does not equal 1. So just looking at the Junior Tutor's answer here, we can see that because we're in a situation where x does not equal 1, so they go through the same process, end up with the same answer, our range is negative infinity to 1. My bad. Let me actually write this a little better. So the range is negative infinity up to 1, but not including 1. So usually if you want to include 1, you use a square bracket, but here we're using a non-square bracket. Up to 1 to positive infinity. So mainly based on this. So this right here, when we did the simplification, ended up with this. We know that the range is this because we know x cannot equal 1. Therefore, the function exists everywhere except that 1. So just going through again, just giving a quick summary. The first step is we flip the x and y. So finding the inverse of the function is flipping the x's and y, and then we solve for y. And then we look at the denominator, and set that to 0, and then this tells us the range over here of this function, of the original function. So the range of this original function is this down here, and this is our answer. So great job, correct answer. So we'll mark this question as correct and move on to the next question. So question number 8. Alright, so this question is asking us, what is the algebraic expression of the quotient of a number and 8? So when we're given this statement, if we're given this statement, the quotient of a number and 8, what does this mean? So looking at the explanation, the quotient is the term used to call the answer to division. Hence the phrase the quotient of a number and 8 means that we are dividing by the number 8. Therefore, if we let x as the number, then we can express the quotient of a number as 8 as x divided by 8. So that's kind of, quick explanation. Okay, this is what this means, just x divided by 8 or some number divided by 8. But I'll go through this with you with this format over here. So when we look at dividing anything, we kind of use this division bracket. So we put the divisor, so let's say it's 8 in this situation, it could be anything, and then we put the dividend down here. So if we said 24 divided by 8, we would have this. That's what we're trying to solve here. And then we know that this is 3, just doing mental math, but essentially, just label these for you. So this over here is the divisor. This is the quotient. And this is the dividend. So that's kind of when you hear the quotient of a number in 8, you can think of, okay, the quotient, we're trying to find the answer to some number divided by 8. That's kind of how to think about it, why this statement is used. So we could say the quotient of a number, any number, and 10, and that would be x divided by 10. In this situation, if the number was x. So this is kind of the example that they're giving here. There's not really much to this other than, having this memorized, so whenever you see this, you're able to identify what this means. But yeah, so we'll mark this as correct. Great job, correct answer. So yeah, let me think if I want to add anything else. I think that's it for this question. So we'll mark this as correct and we'll move on to the next question. Okay, so question number 9. Alright, so here we're asked, how do you factor x squared plus 4? So x squared plus 4. Let me flip the page. So right away we can kind of just looking at this, we can see that 4 is obviously the square root of 4 is 2. So we can recognize that right away. But if we want to factor this, so we want to get it to a situation where we have x plus or minus some term, and then multiply by x plus or minus some term. Right? So we have kind of two components here, and we want to just factor that out. When you look at this, you can't really say that it's x squared, if you want to just solve for x, so let's say you have x squared plus 4 is equal to 0. You want to solve for x squared is equal to negative 4. And then here we can see that if we're trying to solve for x, we have to square root a negative number. If we square root both sides of the equation, you can see that x is equal to plus or minus square root of negative 4. And that's really the main idea here for this question, is that we're square rooting a negative number. So let's quickly go through the junior tutor's answer, and then we'll come back to this. So the expression cannot be factored using a real number coefficient. So we can't do this with real numbers, we need imaginary numbers, or complex numbers. So we can factor this using complex numbers. So they start off saying negative 4 is equal to 2i squared. Okay, so what is this I here? So I'll erase this down here. I'll erase this as well. I'll write this a little smaller as well. So x squared plus 4 is what we're looking at. So let's define what I is. I is just the square root of negative 1. So you don't have to really write square root of negative 1, but whenever you see I, it means square root of negative 1. So when you see, let's say I squared, what does that mean? So you can kind of look at this expression. If you square both sides of the equation, you can see that the square root is gone. We just get rid of it, and we end up with just I squared is equal to negative 1. So that's important to know for this question. That's how we kind of go about getting to this result. So knowing this, let's say we set this to 0, we have x squared equals negative 4. So we move the positive 4 to the other side. We end up with x is equal to square root of negative 4, plus or minus. So we can see that we had the negative. We know the square root of 4 is 2. So we can say it's plus or minus 2. Bring that out to the front of the square root. We still have the negative 1 in the under the square root bracket. So knowing this, we know this right here. So we can just substitute that in. So we know it's plus or minus 2i. That's what x equals. So that's kind of how we get to this point. So essentially they're just defining here that negative 4 is 2i squared. But when you look at this, you can just think, okay, I is square root negative 1. 2 squared is 4. Square root negative 1 is negative 1. So I'll just write that down here. 2i squared. So 2 squared is 4. Square root of negative 1 squared is just times negative 1. And you end up with negative 4. That's why they're claiming this expression. So looking at this below, they say x squared plus 4 is also equivalent to x squared minus negative 4. And looking at this now, we can clearly see that this is a difference of squares, because the negative 4 can represent it as this, and we can see that these two are a difference of squares. So erasing this, we know that the difference of two squares is just anything that's in this format. So a squared minus b squared. So a here is x, b here is 2i. And we end up with this expression. Similarly, what we did over here, we kind of did the same, a different process to get to the same root. So we know x is plus or minus 2i, and that's the case over here. But we know that x squared plus 4 is a difference of squares based on this right here. And we end up with x plus 2i, x minus 2i. And this is the correct answer. So we'll mark this question as correct. So correct answer, great job. But yeah, just to summarize the main idea here, the main thing that you really need to know for this question is this right here. So knowing this, we can use this below. We know that square root of negative 1 is I. We can represent negative 4 as 2i squared, and since we can represent it in this way, we can kind of do some manipulation, algebra, changing operations, and end up with x squared minus 2i squared. And then this is a simpler format for us to look at. Okay, we recognize the difference of two squares. We know the general expression down here is a squared minus b squared is a plus b times a minus b. So there's another important formula to know. So just this right here. So difference of squares you can factor out like that. And that kind of simplifies things a little further. And we'll mark this as correct and move on to question number 10. So question number 10. Okay. So we're given this expression. Let me just take a minute. Okay, so the expression is x cubed minus 1. And our goal is to factor this expression. So one thing you should recognize from this is a difference of cubes. Why is that the case? You can definitely see right away. Let me just use a different color. In this expression, we have the cubed over here. So we know the first term is cubed, but how come the second term is also cubed? Like, why is this cubed? So another way to think about this is this expression is equivalent to x cubed minus 1 cubed. We know 1 cubed is just 1. If you do 1 to the power of anything, it's just 1. So that's where you can say that this is a difference of cubes, because we have this kind of invisible cube. It's not written because we know it is just equal to 1, but we can think about it this way. That's why there's a difference of cubes. So let's look at the junior tutor's answer, and then we'll get back to this. The expression x cubed minus 1 is a special case of binomial. It is known to have two perfect cube terms. With a subtraction sign as the middle operation, this type of binomial is known as the difference of two cubes. Difference of two cubes is a special case of multiplying polynomials. So this is the general format, so I'll write this down here. So I'll write this in a different color, I'll write it in green. So if we had a cubed minus b cubed, so any two variables, any two numbers, a variable and a number, we end up with this format: a minus b times a squared plus ab plus b squared. And this is a very important formula to know for a difference of cubes. And this helps us kind of factor x cubed minus 1 cubed, because right away we can see, just using this template formula, x is a and 1 is equal to b. So we recognize that x is equal to a and 1 equals b. And then right away we've kind of already set up this question to understand how we can factor this out. We really all we have to do is plug in these values into this template equation. So going on with the junior tutor's answer, so the first factor is a binomial, which is the difference of the cubes. So they explain why the a cubed and b cubed are cubed. So if you take the cubed root, we end up with b. Same idea over here. And the second factor is a trinomial, with the first and last term as the square. So they give you the explanation of what the first term here is and what the second term is here, which is correct. And then they apply it to our expression here, x cubed and 1 cubed, and they plug in the values into the template equation. So this is a little more elaborate explanation, but really for this question all you need to know is this template formula. So to kind of apply this, so we know a minus b is x minus 1, and then a squared is x squared, and we have plus a times b, which is x times 1, which is just x, and then we have b squared, 1 squared is just 1, and this is the final answer. So we can look over here, we see that they got to the same answer over here, and we know that this solution is correct. So we'll mark this as correct. So correct answer. Great job. But yeah, once again, whenever you have a difference of cubes, you just go about it by looking at this formula. if you memorize this formula, you'll know how to get to that factoring, how to factor it. Essentially, it's kind of a generic answer because all you really need to know is this formula. But sometimes you end up with these type of questions where you just have to memorize this formula and apply it. Alright, so we'll mark this answer as correct, and this will be the final answer. So this is question number 10 for our session. Okay, so thanks for tuning in to this OneClass session. Hopefully you found these math problems helpful, and we were able to kind of clarify, the solutions to some popular math questions. If you need any more homework help or tutoring needs, you can always visit the OneClass.com website, visit the link in the description, and subscribe to this YouTube channel to find more content like this. Goodbye for now. I'll see you in the next session. Hope you enjoyed.